Welcome to Parents Counseling Their Children and other stories from the world of Kotlin Coroutines. In this presentation, I would like to present you a few interesting facts about those amazing life forms, or at least life cycle forms. How do they relate one to another and how do they live in their natural habituation? My name is Marcin Moskała. I am GD in Kotlin, an official Kotlin trainer, a partner of JetBrains, the author of the Kotlin Coroutines book and the Effective Kotlin book. And I would like to start my presentation with this amazing quote that business is all about relationship, by Brad Sugars. I have no idea if this quote is true or not, and I have no idea who Brad Sugars is, but I am sure about one thing, that Kotlin coroutines are all about relationships. Marcin Moskała, this is one of my many quotes I will present on this presentation. You see, if you have one coroutine like a lunch in here, starting another coroutine like the lunch defined inside it, there is a relationship between those coroutines. We say that there is a parent-child relationship. The coroutine that is the outer one is a parent of those that are inside. You might also notice that lunch is a children of a scope. How is it possible? Just take a look at the definition of lunch, and you might easily notice that lunch provides a receiver for its lambda expression. So the coroutine scope here is used as a receiver, what means that the lambda expression used when you call this lunch has an additional meaning to the word this. This meaning is the coroutine scope. The word this refers to the receiver. And you might also notice that lunch is an extension function on coroutine scope. So lunch needs to be called on a coroutine scope. So how is it possible that lunches inside lunch are not called explicitly on anything? It is because they are called implicitly. So under the hood, this lunch is called on the receiver. So it is like this.lunch that is called. So in other words, the parent coroutine creates a scope that is used by children coroutines to build relationship with their parents. And as mentioned before, lunch that starts it all is in relationship to the scope object. Scope is not a coroutine, it's just a scope, but it can be in relationship with a coroutine anyway, so I marked it differently, and it is part of our relationship. In some cases it might not be so clear that the relationship is there. So for instance, if you have a function coroutine scope that is used to wrap over suspending function, such a function also creates a coroutine, and such a coroutine is also a children of a coroutine that calls this suspending function. So coroutine 1 in here is of course a children of a scope, but then coroutine 2 is a children of coroutine 1, and coroutine 3 and 4 are children of coroutine 2. How is it possible? So the relationship between coroutine 2, 3 and 4 is relatively clear. Coroutine scope creates a scope, so it overrides, it adds a receiver of type coroutine scope, and both async functions are called on this receiver. However, how is it so that there is a relationship between coroutine scope and lunch? To understand that, you need to know that all suspending functions have an additional parameter of type continuation. So when we call suspending function, there is this continuation object passed into this suspending function. And a continuation object is needed for coroutines to work properly. And one thing it has is context of this of the coroutine that calls this suspending function. And inside this context, we have a job, and this job is used to build relationship. A fun fact about Kotlin coroutines is that Kotlin coroutines build relationships through their jobs. This might not be an acceptable behavior in our community, but it seems to be a standard among Kotlin coroutines to build relationships through their jobs. That's the standard way for them, and we should respect it. Now you might be wondering why? Why do we need those relationships among or between coroutines? If you take a look at other languages that use coroutines, you will not find this scope. So for instance, if you take a look at JavaScript that uses async functions, async await needs a coroutine. So this is an example of a JavaScript coroutine, a limited one, comparing to Kotlin, but still a coroutine. And we see no scope in here. So this scope does not seem to be absolutely necessary if JavaScript does not need it. So why do we need to have it in Kotlin? And the answer is because Kotlin coroutines support features that are not supported or not well supported by other languages. And for those features to work properly, we need to have scope. And so let me show you what features do we have as a consequence of having a scope. So the first thing is context propagation. So when you start a coroutine with some context, like a lunch in here has a context coroutine name, this context is automatically propagated to its children's. So not only this lunch has the context, but also all its children's. This is very important because based on this mechanism, many other mechanisms work. It is also used, for instance, in backend to include a context with information about request. You know, coroutine is used to handle some request, so we can pass information about this request as a context. Thanks to that, it is later to read some parts of this information. Context propagation is also very important for testing coroutines properly. It is a very important and powerful mechanism that has many interesting uses. And so you might remember that children inherit context from their parents, as we all do, what is sometimes cheerful, sometimes depressing. However, good news is that they can change it. They inherit their context, but they can change it. So each coroutine can specify its own context, and this context overrides this specific context key for the concrete children. So each children can modify context passed from its parent. So in here, name 2 overrides name 1. Another important thing to notice is that context is also propagated through suspending functions, thanks to the continuation context property, as mentioned before. And so coroutine scope still has this context taken from its parent, and it also passes that to its children. So context is not lost if we are properly using structured concurrency, if we are keeping proper relationship between our coroutines. So from this parent we pass the context to the suspending function, from suspending function to coroutine scope, from coroutine scope to its children's. At this point, many people ask me, what about with context? With context is a function that is that works the same as coroutine scope, but it also supports context overloading. So if you need to modify a context for a suspending function, you use a coroutine scope, and it also use a with context, and it also creates a coroutine scope. If you do not need to do that, you use a coroutine scope and context stays the same, but you are only creating a scope. In other words, with context, with empty coroutine context, give the same result as just using coroutine scope. At this point, many people ask me why there are two different functions, why there is no just possibility to call coroutine scope with an additional argument that is the context for this context override for this scope. And this reminds me a very old Polish saying that can be translated as, if grandma had a mustache, she would be a grandfather. It's a popular Polish proverb, and we can adapt it to the Kotlin coroutines word and say that if coroutine scope had a custom context, it would be with context. That's why coroutine scope does not have a custom context, because then it would be with context, and that's my explanation. Okay, another very important mechanism is scope cancellation. You see, the word of Kotlin coroutines seems to be tough, and a cancellation of a parent always leads to cancellation of all its children's. Those children's cancel their children's, those children's cancel their children's, and in the end, everyone under this scope are cancelled. This is a very important mechanism, especially on front-end. Imagine that you are writing an Android application and your user opens an activity, a window, and immediately closes it. So you need to cancel all the work you started, because when you open a window, many things often start loading for this window. But when someone closes this window, you need to cancel those processes, because if you do not cancel that, they will be going in background even though you do not need them, and trying to update views that do not exist anymore. So cancellation is very important for Android. It's also important for backend for efficient resource use. The processes that are not needed should be cancelled. So here we have a simple example. On a start we call launch. On a launch we call coroutine scope. On a coroutine scope we call two asyncs. If you cancel scope, scope.cancel, bam, you cancel scope, scope cancels its children, children cancels its children, that cancels its children. You can also cancel children's without cancelling scope, but by itself. For that, you use scope.coroutineContext.cancel children. And that's a pretty useful thing, because this way you are cancelling all the processes without cancelling scope itself, so that it can be used in the future for another processes. So you can cancel a children without cancelling its parent. Another important mechanism is exception handling, and this one seems to be a bit conceptually harder than others for many people who learn about that. But it actually seems to be quite intuitive once you understand it well. Because, you know, if you have an application where you have an exception, this exception, if not handled properly, if not caught at any point, breaks your program. It propagates up until it breaks your program. So if you have coroutines that do not catch any exceptions, and you have an exception in one of those coroutines, it should be quite expected that this coroutine should cancel its parents. You know, it should the coroutine that has an exception, bam, should break itself, then it should propagate to its parent, bam, then parent should cancel its children's, and then it should propagate to its parents. And this way it should propagate until everything in the scope is cancelled. That actually seems quite intuitive. This is how the exception handling should work. You know, if you do not catch exception that has happened, you should cancel things that are happening, but also the things that has started them. So the question is, how can we deal with exceptions? How can we handle exceptions more safely? Notice that here I used a regular job. This is a rare combination of using coroutine scope with a regular job, because in regular situation we use a coroutine scope together with a supervisor job. You see, supervisor, a synonym for a boss. Supervisor job makes a special kind of relationship with its children. You know, when a parent has a supervisor job, it basically ignores all its children's problems. So if you have a coroutine that uses a supervisor job, all its children's problems are ignored. They do not touch us. So in this particular case, scope has a supervisor job, and so an exception in its children, it ignores it. Okay, an exception will be still displayed, but it will not break the scope. So supervisor job is one way to silence exceptions. However, this supervisor job needs to be a part of a coroutine. And here's a tricky thing, because a job is the only context that is not propagated into a coroutine, but when you pass it to a coroutine, it will be used as a parent of this coroutine. You see, each coroutine creates its own job, and you cannot make coroutine use a certain job. You cannot do that. You can only give it a job to use it as a parent. So if you pass a supervisor job to a coroutine, it will be a parent of this coroutine. And this will not work as many people would expect, because an exception on one coroutine, bam, breaks the parent, that is the lunch, cancels children's, and then is ignored by the supervisor job. And so what? It does not behave like we expect it to. And this is a huge anti-pattern, because notice that this supervisor job breaks the relationship to the scope. As we said, coroutines build relationships through their jobs. So right now, lunch is in a relationship with a supervisor job, not with a scope. So if you cancel a scope, you will not cancel those coroutines 1, 2, and 3. What is very important. So you broke your relationship. You should never do that. It should never take place. So don't do that. The same thing in here. Do not use a job as an argument to a coroutine, because it breaks relationship to its parent. Notice that this lunch, the coroutine 3, is not a children of a coroutine 1. It is a children of a job. It will still inherit context. Coroutine 3 will still inherit context from coroutine 1, but that's all. The scope cancellation will not affect coroutine 3. There is an exception. There is a typo in this slide. The parent of coroutine 1 should be scope. So an exception here breaks the job. It does not propagate, but we are losing much more than we think we do. Exception handling behaves very specifically when we use coroutine scope function. Because coroutine scope functions throw exceptions instead of breaking their parents. What is a very important thing to notice? So if you have an exception on this async function, bam, it propagates to the parent, so the coroutine scope. It cancels other children's, what is very important, because if one async function has an exception, it's very likely you want to cancel others as well. And this is for our memory, this is for our proper resources usage. Not just consider the fact that this process might be heavy and expensive and you will never need it anyway because parent is broken. So you cancel the other async functions, but then instead of breaking the parent, you are throwing this exception and you can catch it. And so here cot will be printed. So coroutine scope functions throw exceptions instead of breaking their parents. At this point, someone might ask, but what if you want to ignore exceptions in a children's? So like in here, an exception in async broke other async functions and broke the parent. What if you want to ignore exceptions in other children's? We have such situations if you have functions that starts multiple independent processes. Like in here, our load badge starts two processes. One of them is to request news, another one is who knows what, but it is failing anyway. So since we used supervisor scope instead of a coroutine scope in here, an exception on a lunch is literally ignored. So that's it. We do nothing with this exception. It will be still displayed, but it will not break other children's. Okay, so let's summarize our coroutines folk wisdom I've presented on this presentation. So first of all, coroutines build relationships through their jobs. Children inherit context from their parents, but they can change it. If coroutine scope had a custom context, it would be with context. When you cancel a parent, it cancels its children too. When a child is broken, it breaks its parent. That's a tough story, but that's how it works. When a parent has a supervisor job, it ignores its children problems. When children has its own job, it loses connection to its parents. It still inherits context, but it basically loses connection to its parents. And finally, coroutine scope functions throw exceptions instead of breaking their parents. It was a huge summary of how coroutines work and relate one to another. I had much more to say about that. The book Kotlin Coroutines I wrote is in big part dedicated to coroutines and their relationships and the specificity of different ways to start coroutines. I also have workshops about it. One of my most popular workshop on kt.academy is Kotlin Coroutines, 2 days dedicated for Kotlin Coroutines. Very efficient workshop, very well received. And so if you want to learn more, I'm sending you to the website, and I will be happy to conduct it for your company, or if we have some open edition to teach you on this open edition. That was everything I had for you. Thank you for your attention. My name is Marcin Moskała from kt.academy, and this was Parents Counseling Their Children.